Yeah, we discussed about the illumination under the illuminations of the polar curve. Then we discussed about the polar curve we used to determine the MHCP, and the another one is MSCP. These are used to determine the actual illumination of a surface by employing the candle power in that particular direction. So what is this maintenance factor? This maintenance factor is nothing but it is the ratio of illumination under normal working condition to the illumination when the things are preferred clean is known as a maintenance factor. And perfectly clean means illumination under normal working condition divided by illumination when everything perfectly clean. Okay, you can say also in this way. Depreciation factor means it is defined as the ratio of initial meter candle to the ultimate maintained meter candle on the working place. It is also the inverse of the maintenance factors. It is the inverse of the it is the ratio. You can say that it is the defined as the ratio of initial meter candle to the ultimate maintained meter candle on the working place. It is also inverse of maintenance factor. 1 by maintenance factor is called as a depreciation factor, you can also say, and its value is more than 1. Okay, and you should clear about that its value is more than 1, and it is a 1 by depreciation factor is known as your maintenance factor, you can say. So there are types of lighting scheme. There are different types of lighting scheme. The distribution of a light emitted by a lamp is controlled by a means of a reflector and the transparent diffusion screens. The interior lighting schemes are classified as direct lighting, semi-direct lighting, indirect lighting, general lighting. Direct lighting means it is the most commonly used type of lighting scheme. In this scheme, more than 90% of total light flux is made to fall directly on the working plane with the help of a deep reflector. It is the main use for industrial and general outdoor lighting. Okay, so semi-direct lighting. What is this semi-direct? That means in the lighting scheme, 60 to 90% of total light flux is made to fall down directly with the help of semi-direct reflector. Remaining the light is used to illuminate the ceiling and walls. Such as a lighting scheme is best suited to rooms with the high ceiling where a high level of uniformly distributed illuminated is desirable. So semi-direct lightings we discussed, that is a semi-indirect lighting. It is a semi-direct lighting. Another is semi-indirect lighting, another is indirect lighting, another is general lightings. So semi-indirect lighting, what is that? In this lighting scheme, 60 to 90% of total light flux is thrown upward to the ceiling of a diffuse reflection, and the rest reaches the working plane directly except from some absorption by the balls. The lighting scheme is with the soft shadows and glares free. It is mainly used for indoor lighting decoration purpose. Indoor lighting decoration purpose we use semi-indirect lighting purpose, and 60 to 90% of total light flux is thrown upward to the ceiling of a diffuse reflection. So indirect lighting means in this lighting scheme more than 90% of total light flux is thrown upward to the ceiling, and for diffuse the reflection by using a inverted or balls reflector. In such a system, the ceiling acts as lighting source and the glare is reduced to minimum. The resulting illumination is softer and more diffuse. The shadows are more prominent and the appearance of a room is more improved, over which that a result from a direct lighting. It is used for decoration purpose in cinemas, theaters and hotels, and in workshop where the large machine and other and obstruction would cause the troubles some shadows in if direct lighting is employed. General lighting. What is this general lighting? In this scheme, lamp made of diffusing glasses are used, which gives a nearly equally illumination in all directions. So next come to the topic, we will discuss about some lamps. There are different types of lamps. We know that there are different types of lamp. Fluorescent lamp is there, mercury vapor lamps is there, LEDs are there, and neon lamps are there, and cold cathode lamps are there, and different types of lamps are there. Mercury vapor lamp, uh, fluorescent lamp. So we will discuss first. We discuss about the fluorescent lamp. So what is this fluorescent lamp? So see here, it is the visible, and it is the diagram of the fluorescent lamp. Okay, clear? So here what happened actually, here you can know that this is a fluorescent tube and electrical choke is present and starter is present. Okay, so what is the purpose of this fluorescent tube? You can see here, this is the pin and this is the base, and this is a phosphorus coating. Inside the tube is a phosphorus coating and the seal with a glass tube. That means they are sealed, and inside the tube mercury vapors are present and some noble gases are present, and this one is a cathode. Clear? This is the fluorescent tube. So you can know about this fluorescent tube in pictorial representation. You know about this. And what is this fluorescent lamp actually? So that means we can say this is the fluorescent lamp. Okay, in a mercury vapor lamp we can consider the amount of radiation is in the ultraviolet range. By coating inside the tube of phosphorus, this ultraviolet radiation is converted into a visible light. That's why we put here in the coated with the phosphorus. Phosphorus have a definite characteristics color, but when mixed together they produce a large variety of colors. These phosphorus are stable compound and give a high output throughout the life of the lamp. There are three types of fluorescent lamp: iron cathode or cold cathode lamp, tungsten cathode or preheated lamp, tungsten cathode or cold. So you can say these are different types of fluorescent lamp, but we consider this is the figure. We know that what is this electrical choke and what is this tubes. We will discuss. A fluorescent tube called a long tube with a electrode in each end. You can see the electrode in each end. Both end you can see. Suppose you consider this end is a F1 and this end is considered as a F2. In the fluorescent we have two ends, that is F1 and F2 we can consider. So that means here a fluorescent tube consists of a long tube with a electrode in each end. Inside the tube is coated with a fluorescent powder. You can see here it is coated with a fluorescent powder. Okay, and a choke of a high reactance is connected in series with the filament and a starter as shown in figure. So choke is high reactance connected in series with the filament. You can see here the diagram. You can see choke is connected in series with the filament lamp. That is called the electrical choke. Generally we use different types of choke. We use electronic choke. At that time we not record any starter. So in electrical choke, that is called the copper choke, we need a starters. Okay, starter is nothing but is a one type of bimetallic strips. Okay, this is the bimetallic strips. Okay, so now come to the points. Here you can see a starter is connected in between the two filament F1 and F2 as shown in figure. There is also capacitor is present inside the starter. So that means inside the starter your capacitor is present. Here suppose you consider this one is a F1 and this was the F2. So here a capacitor is connected. So in between the two F1 and F2. Okay. So copper choke. What is this copper choke? It is it consists of a coil wound with a copper wire on laminated iron core. It is connected in series with the tube when the circuit is on. The high voltage ones of the tube electrode which starts the electron emitter to start the radiation of light. Okay, that is called a copper choke. So, yeah, you can see this diagram here. We consider here F1. You consider this one as F2, and this one is F1, and this one is F2, and it is a choke. Choke is nothing but the blast. Although the name is choke, but here supply is given, and here in this way it will work. So, come to the topics that we have this type of aluminum cap, and glass stream is there, and cathode steel is there, electrode coil is there, liquid mercury is there, argon krypton, that is a noble gas, and phosphorus coating is there, and this one is a glass tube. Everything is there in a fluorescent tube. So this is a fluorescent tube lamp. Phosphorus coating, you can see this is a phosphorus coating. In a fluorescent tube, a very small amount of mercury mixes with a inert gases to conduct the electrical current. This allows the phosphorus coating on the glass tube to emit a light. This is the important point. So what is this important point? Says that in a fluorescent tube, a very small amount of mercury mixes with inert gases to conduct the electrical current. This allows the phosphorus coating on the glass tube to emit light. This is the important point you have to remember. So you can know this. The base with a bipin plug. This is the base with a bipin plug. Inside that it is present in this way. Mercury and inert gases are present in the tube. You know all these things. So come to the structural. So the fluorescent tube consists of a glass tube 25 mm in a diameter, and 0. mt and 12 mt and 1.2 mt or 1.5 mt in length, and the tube contains argon gas at low pressures of 2.5 mt meter and 1 or 2 drop of mercury, and inside the surface of the tube is coated with a thin layer of fluorescent material in the form of a powder. The coating material is used depends upon the color effect desired and may consist of a zinc silicate, cadmium silicate, calcium tungsten. These organic chemicals are known as phosphorus with a transformer short wave invisible radiation into a visible light. At start, the current is passing through the filament which gets heat up and emits the electron. This achieves by use of choke with a starter. That can be achieved by use of choke with a starter. So the choke is connected in series with the tube which acts as a blast in a running condition and provides a high voltage impulse or surge for starting. At the time when the switch is operated, the starter is provided and the electrodes get heated and start emitting sufficient electron. This switches or starter are two types. There are two types of starter, but generally we use in glow type starter only. Okay. So what is this glow type starter? There are two types of starter. There is thermal starter and all this glow type starter. So what is this glow type starter? Is the glow type starter is a type of preheat starter used with a fluorescent lamp. It is commonly filled with a neon gas or argon gas and contain a bimetallic strip and a stationary electrode. The operating principle is simple. When a current is applied to the gas inside the ionization and the heat, a bimetallic strip which in the band towards the stationary electrode. Thus, the sorting the starter between the electrode of a fluorescent lamp. After a second, the starter bimetallic strip will cool and open the circuit between the electrode, and the process repeat until the lamp has lit. So one disadvantage of the glow type starter is that when the lamp is at the end of its life, it will continuously blink on off until the glow which starter wears out or an electrode on the fluorescent lamp is burnt out. This is the thing of a starter. We generally use a stutter, there is blow type stutter operating. It is the same when current applied to the gas inside the heat is bind in the stream with